All right, so here's the first of 4 examples we're going to do of surface integrals of scalar functions. And if you get bored, you can maybe stop following these examples, but they are all kind of different. So if you have time, maybe watch all of them. Okay, so we want to find this surface integral. There's the function. And then here's the surface. It's the portion of some surface, I'm not really sure what that looks like, over a triangle with these vertices. And this triangle is in the xy plane. So what's nice about this is that it's already a function of z. So I'm not so concerned about drawing a picture, because I know there's some triangle down here, whatever that looks like. That's not really a triangle. Let's try to make it a triangle. And then there's some surface up here, and it says over, so I'm going to trust that the surface is up here, and I'm not going to worry too much about it. It's some curvy thing whose shadow is this triangle. Okay, so then I can just kind of do the math. Let's see. So I need to parameterize this surface in 2 variables. Well, it's already in z equals format, so actually maybe it's not that hard. Maybe I can just parameterize it in x and y. I can use any 2 letters I want. I was using u and v in last week's videos, but you don't have to do that. So if I just parameterize it in x and y, then x is x and y is y, and then z is that function, 2 minus 3y plus x squared. It's now parameterized, and then whatever 2 variables I'm in, I can take my partial derivatives with respect to those variables. So I get 1, 0, 2x for our x, and for our y, I get 0, 1, negative 3. Okay, so now I'm ready to calculate my cross product, rx cross ry. Maybe we'll write it like this because it's a determinant, but ijk here, 1, 0, 2x, 0, 1, negative 3. And then that is negative 2x, comma, positive 3, comma 1. Make sure you get that. And so then the magnitude of rx cross ry is the root of, I get 4x squared plus, this is 9 and 1, so I get plus 10. Okay, so that goes inside my integral, and then I also have this function. Notice how similar this guy, I meant to highlight that. Notice how similar this guy looks to this guy. In fact, I can just collect everything on one side. Really, the surface is z plus 3y minus x squared equals 2. So if I stay on this surface and I'm integrating this value is always 2. Okay, so I just need to integrate then 2, and then this is part of my ds. So I have root, I'll write that a little better, root 4x squared plus 10, and then I'm in x and y, dx, dy. And then, okay, so what do x and y range over? That's where I need to look at this triangle. So 0, 0, 2, 0, 2, negative 4. I'm going to remember that. So now I'm in the xy plane. It's a lot easier picture to draw. I go 0, 0, 2, 0, and then 2, negative 4 is here. So I have a triangle with these vertices. It doesn't really matter what order I go in. I'm going to go, I think this will be easier, if x goes from 0 to 2, so I'll actually switch the order, which we can do if everything is nice, which most of the time it is. So x is going to go from 0 to 2, and then y is going to go, this is the line y equals negative 2x. We can see that because 4 is double of 2. So y is going to go from negative 2x to 0. Okay, great. So now I just integrate this 0 to 2. There's no y's here, so this is 2 root 4x squared plus 10 y outside the root. And then y goes from negative 2x to 0. Still need to integrate with respect to x later. And then plugging in those bounds, I get 0 minus this negative, minus negative. So I actually get positive 4x, because I still have that 2 there, root 4x squared plus 10 dx. And now maybe I'll just do a quick u substitution. And then du is 8x dx. So 4x dx, which is what I have, I always like to sub what I have, is 1/2 du. Okay, so then I have 0 to 2, I have a 1/2 du back here, that's subbing out 4x dx, and then subbing out this is root u. And then I haven't changed my bounds, so optional, but I'm just going to write x equals 0 to x equals 2. And then I will integrate. So this is to the power of 1/2. I go to the power of 3/2. I get a factor of 2/3 in front, so I have multiply that with 1/2 to get 1/3. Going from x equals 0 to x equals 2. And then maybe I'll sub back in now. So 1/3 4x squared plus 10 going to the 3/2, going from 0 to 2, and these aren't really nice numbers, so I'm going to get actually 1/3. It's going to be 26 to the 3/2 minus 10 to the 3/2. If I want, I can write that maybe as 26 roots 26. Power of 3/2 just means power of 1, and then another power of 1/2 with exponent rules. So maybe that's the most simplified. Don't know. This would be fine if you left your answer that way. All right, so there's one surface integral from beginning to end.